In this video, we're going to talk about how to solve systems using the calculator to perform Gauss Jordan elimination. So remember, we said that there are three ways to solve systems that we've already been talking about. So we talked about algebra, and then we talked about matrices with Cramer's rule, and then Gaussian elimination. So we can expand on Gaussian elimination with Gauss Jordan elimination. So why do we even do this? Why do we have a whole other system? So the reason we have this is because Gauss Jordan elimination does not require back substitution. So remember, we were in Gaussian elimination, we were transforming our matrix to row echelon form, and then we were writing out the equations and then solving our equations. Well, that whole solving our equations part is not needed in Gauss Jordan elimination. Another advantage of this is that our graphing calculator can actually do Gauss Jordan elimination for us. So what we're going to do in Gauss Jordan elimination is transform our augmented matrix into now reduced row echelon form. Okay, so rref. So that's different than row echelon form, which was ref, right? That's what we were using in the previous video. So here's what reduced row echelon form looks like. So here's our augmented matrix, and this is reduced row echelon form. So this part that we have here on the left, that's the identity matrix. Notice that it's composed entirely of zeros and ones, and the position matters. Notice that we have our ones on the diagonal, and then every other entry is a zero. And so what this does is it actually just fully solves our system for us. So from this matrix, we can actually tell the values of x, y, and z, right? Because if you see, if we convert this into an equation, we'd have x equals a, y equals b, and z equals c, right? These three numbers right here. So in this example, we'd say that x equals 7, y equals 5, and z equals 3. Okay, so reduced row echelon form fully solves the system for us. So, how would you do this by hand? And in some college classes, like if you take a linear algebra class, you will be doing this and writing out all your steps. So you can actually do this, right? Because we know all the row operations we need to do. And it's just going to require a lot more row operations than we've been doing to solve this, right? So you can see here, I fully wrote out my work. So if you're curious, like how I would take this augmented matrix and turn it into reduced row echelon form, I wrote out all the steps for you. Okay, so we just work on forming the zeros. You can see I have my two zeros in column one, and then I start forming my zeros in column two. You see that this pattern starts to emerge, right? So I'm getting closer to getting my ones on the diagonal. And then when we go to the next page, you see I have my ones now. I just need to worry about forming these zeros. So you just keep repeating these steps until you get this pattern that we need, right? So this identity matrix on the left, and then we have our fully solved system of equations. So it does take a little bit of work and it does take a little bit of practice to get used to. But like I said, you know everything you need to know to be able to do this. It's just that it's a little bit lengthier process. And it's kind of like solving a puzzle. So that's, if you're curious and you want to know how that works, that's there for you. But, in this class, we're just going to use our graphing calculator to do this. Okay. We have this rref function on our graphing calculator, and that's going to give us the reduced row echelon form. So all we need to do is enter our augmented matrix and then tell the calculator to perform this function, and it will fully solve this system for us. So here are the steps. So I'm going to use this same system. So that system that had this augmented matrix, I'm going to use that as my example as I work through this. So remember, we're going to go to second and then x to the negative 1 to open our matrix menu. So arrow twice to the right to open the edit menu and then choose matrix A. So since we have an augmented matrix, this is going to be a 3 by 4 matrix. So we just do 3, enter, and then 4, enter. So when we enter this in our calculator, it's not going to have that line there, but it's okay. The calculator will figure out that it's an augmented matrix once we tell it to do reduce row echelon. So we don't need to worry about that. So let's go ahead and enter our values. So we have 2, enter, 1, enter, negative 4, enter, 7, enter, and then 2, 4, 2, and then 40. And last row, we have 6, negative 2, 4, and 44. Okay, so make sure you scroll back and just double check that everything's been entered correctly. You will have to scroll right because the window's not big enough to see everything at the same time. And just double check this last column also. So if everything looks good, we're going to do second mode to return to the home screen. And now we're going to tell it to find the reduced row echelon form of A. So we do second matrix, and now we have to choose the math menu. Okay, so that's where we have all the functions that will do math on our matrix. So we're going to scroll down until we find reduced row echelon. Okay, so be careful because it has row echelon in there, but we don't want to choose that. You want to look for the two R's. Okay, and that's going to be option B, reduced row echelon form. So we hit enter there, and then we're going to do second matrix. And then from the names menu, we're going to choose matrix A. And then when you hit enter, it does some computations and it gives you your solution. Okay, and remember the solution we can write as an ordered triple. And as an ordered triple, this is going to be 753. Okay, so all those, that long list of calculations that I had written out, the calculator just did that for us in about, probably less than a second, right? So that's how we're going to use our calculator to do reduced row echelon form. Okay, so that's our strategy, right? We can solve 3 by 3 systems by setting up an augmented matrix that our calculator will convert to reduced row echelon form. So here's what we're going to do. So we're going to start off making sure that all our equations are in standard form. Then we'll set up an augmented matrix A and note its dimensions, and we'll enter matrix A into the calculator. Using the matrix menu, we're going to use B, which is reduced row echelon form, to find the reduced row echelon form of matrix A. And the last column of the matrix in reduced row echelon form, remember, will give you the solutions to the system of equations. And finally, we will write our solution as an ordered triple x, y, z. Okay, so let's go ahead and solve this system using now this new function on our calculator. So remember, I'm going to enter my coefficients of 1. So I'm just going to go ahead and add those in. And let's set up the augmented matrix. So row 1 is going to be 1, 2, 1, and then 9. And then we have 2, 1, 3, 0, 3, -4, -5, and 1. Okay, so that's my augmented matrix. So I'm going to now go to second matrix and then go to edit and then choose matrix A. So it is still 3 by 4, so I'm going to leave that alone. And then I'm just going to start typing in my values and it's going to overwrite what I already have there. Okay, so I just go ahead and enter row 1 and just type, each value and then hit enter afterwards. So then I have 2, 1, 3, 0, and 3, -4, -5, and 1. Okay. So remember, always scroll back and just double check that everything has been entered correctly, that all your negative signs and things like that are correct. So we're going to do second mode to return to the home screen. I'm going to clear that because that was from my last problem. And then I do second matrix and now go to the math menu. Scroll down until you find reduced row echelon form and then hit enter. And now go to second matrix, and then from the names menu, we're going to choose matrix A. And then when you hit enter, it gives us our solution in reduced row echelon form. So when we write this as an ordered triple, it'll be 2, 5, -3. All right, so let's practice with another example. So here we have this system of equations. So once again, I'm going to go ahead and add in my coefficients of 1 for my variables that don't have coefficients. And let's write out the augmented matrix. So we have 2, 1, 1, and then 1. And we have 3, 2, 3, and 12, 4, 1, 2, and -1. So now let's go to second matrix and then go to edit and hit enter. It's 3 by 4, so I'm going to leave that alone. So 2, 1, 1, 1. And then row 2 is 3, 2, 3, 12. And row 3 is 4, 1, 2, and -1. Okay, so just scroll back and just, quickly make sure that everything looks correct. And then we click second mode to return to the home screen. I'm going to clear what I have there and then go to second matrix and go to the math menu and choose option B, which is reduce row echelon form. Hit enter and then go second matrix. And then from the names menu, we're going to choose matrix A. So hit enter and then it does give us our solution. So we're going to write that as an ordered triple, which is -4, 3, 6. And now that is solved. Okay, so now you can go ahead and pause the video and practice doing this problem on your own. the solution to the system, you can see that I went ahead and set up the augmented matrix like I've shown here. And then I entered this into the calculator under the edit menu. And then I did second matrix. And then from the math menu, I chose reduced row echelon form. And then from second matrix in the names menu, I chose matrix A. And then when I hit enter, it gave me the solution, which is x equals -1, y equals -5, and z equals 7. So now remember when we talked about solving systems, we said that we may encounter systems that have no solution or infinite solutions when we're solving. Remember that if a system has all three planes intersecting in a line or in a plane, we'll have an infinite number of solutions. If all three planes have no points in common, all three of them, that means we'll have no solution. So what does this look like when we're solving using reduced row echelon form? Well, we can tell based on how the matrix looks, okay? So what we're going to do is we're going to look at the very last row of the matrix. If it's all zeros, that's like basically the calculator telling us that 0 equals 0, okay? And that's something that's always true, so we're going to have infinite solutions in that case. If the last row of the matrix looks like this, if we have all zeros and then a 1, that's basically like the calculator telling us that 0 equals 1. And we know that's never true. So that's a situation where we'd have no solution. So let's try some practice problems. So let's try solving this system. So I'm going to start off by setting up my augmented matrix. So I have -4, -2, -1, 15. And then I have 12, 6, 3, -45. And I have 2, 5, 7, and -29. Okay, so now I'm going to go to my calculator, second matrix, and then go to edit, and I'm going to enter these values. So I have 3 by 4 matrix, and then I have -4, -2, -1, and 15. And then I have 12, 6, 3, -45, 2, 5, 7, and -29. Okay, so I'm going to scroll back and double check that everything looks right and it looks good. So I'm going to do second mode. And then I do second matrix, and then I go to the math menu and scroll down until I find reduce row echelon form, which is B. So I hit enter and then do second matrix and then choose matrix A. And then when I hit enter, well, look at my last row. It's all zeros, right? So when I have all zeros, that's basically telling me that 0 equals 0. So I would say that this system of equations has infinite solutions. Okay, so whenever you get something that's always true, like 0 equals 0, that's going to be infinite solutions. So now let's try this example. So let's go ahead and set up our augmented matrix. So I'm going to have -6, -9, -12, and 21. I have -2, 3, -4, and 7, and then 10, -15, 20, and -30. Okay, so once again, I'm going to go back to second matrix and then go to edit. It's 3 by 4, and then I'm going to enter my new values. So -6, -9, -12, and 21. And then we have -2, 3, -4, and 7. And then we have 10, -15, 20, and -30. And just scroll back and double check that everything has been entered correctly. And it looks good. So I'm going to do second mode. And then I do second matrix, go to the math menu, scroll down to reduce row echelon form, which is here, hit enter, and then do second matrix. Choose matrix A from the names menu and hit enter. And now you can see that it gives me a very strange looking matrix, right? My last row is 0, 0, 0, 1. So it's telling me that 0 equals 1, which makes absolutely no sense. So I have no solution to this system of equations. So remember, there are 3 ways to solve 3 by 3 systems. So now you've done it. You've learned all 3 ways. You know how to solve systems algebraically, matrices with Cramer's rule, and Gaussian elimination. And we even took Gaussian elimination expanded one step further, and we learned how to do Gauss Jordan elimination on our calculator. So you have done it. You have mastered solving 3 by 3 systems. So remember that we can use an augmented matrix to help us solve a system of 3 by 3 linear equations. So using our calculator, we can transform an augmented matrix to reduce row echelon form, which will tell us the solutions to the system.